Hi everyone, this lesson is on evaluating logs and the power law. And just a reminder that the logarithmic function is the inverse of the exponential function with the same base. So the logarithmic function is most useful for solving for unknown exponents. So like for example, if I have 7 equals 3 to the power of x, it's really hard for me to solve for x right here because the x is part of the exponent and the log helps me pull that out, okay? Common logarithms are logarithms with a base of 10. It's not necessary to write the base for common logarithms. So for example, if I say log of 100, the answer to this is 2 because this is log base 10 of 100, and 10 to the power of 2 would give us 100. Okay, so state the inverse function of y equals 5 to the power of x. So remember an inverse, you would just swap x and y. So this would become x equals 5 to the power of y. But whenever we want to write out our equation, we always want to write it out as y being isolated. And the only way you can isolate the y here is to write this in a log. So this would be log base 5 of x, just like we learned in the last lesson here. And because this is the inverse, we'll say y inverse is log base 5 of x. Okay. Now, we have two really important rules here. The first rule is if x to the power of a equals x to the power of b, then a equals b. We use this rule when we are solving exponential equations. If you have two different sides of an equation with the same base, the exponents have to be equal to each other. But here's another really helpful rule, and that's that log base a of a to the power of b is b. So for example, if I have log base 7 of 7 to the power of 2, the answer here would have to be 2. Why is that? Because right here, if I write log base 7 of 7 squared, let's say I don't know what it is, I'll call this x. What this means right here is 7 to the power of x is going to equal this value right here. And now I can use this rule and say that x equals 2. So I can just go straight to that now using this rule right here. Okay, so evaluate the following without the use of a calculator. We're going to use both rules in this first example here. So one way you could do this is by using the first rule. I'll call this x. I'll set this equal to x. So now what this is saying is 5 to the power of x equals 25. Get a common base, which is 5. So therefore x equals 2. Okay, or I could use this rule right here by rewriting log base 5 of 25 as log base 5 of 5 squared. 25 and 5 squared are the exact same thing. Well, now we've got the base here and the base here, those match, just like we've got log base a of a to the power of b. So now we can just say that this would be the exponent right here. So your answer here would be 2. Okay, so let's take a look at this next example here. We can say log base 3 of 1 over 27. Well, I can rewrite this as 3 to the power of negative 3. So the answer here is negative 3. Okay. For c, I can say that this is log base 5, and then this is the cube root of 5. Well, the cube root of 5 is 5 to the power of 1/3. Now these match, so I can say that this is 1/3. And then here, we can say that this is 2 times log base 5 of 5 squared minus log base 10 of, remember this is an invisible 10. If there's no base there, we can automatically assume it's a 10. And then I'm going to say 10 to the power of 0 because 10 to the power of 0 is 1. So this would turn into 2 times. Now log base 5 of 5 squared is 2. And then minus log base 10 of 10 to the power of 0 is 0. So it'd be 4 minus 0, which is 4. Okay, so now we're going to talk about the power law of logarithms. And this is a really helpful tool when we're dealing with logarithms, but we need to actually identify what it is. So that's what we're going to do here. We're going to kind of just figure out or derive the power law of logarithms. So this says let log base a of m equal b, which means that a to the power of b, right? A is our base, b is our exponent, will equal m. Like that's the definition of a logarithm, right? Okay, so the power law, I want to know, well, what happens if there's a power? So I'm going to write log base a of m, and then I'm going to add in a power. So we're going to call this power n. And I want to know, well, what's going to happen if I have this power right here? Well, for starters, we know based on this right here that m is equal to a to the power of b. So I can replace this m right here with a to the power of b. So I would say here log base a of m, which is also a to the power of b, and then that's going to be all raised to the power of n, because we have this n right here. Well, remember, when you have a power to a power, you need to multiply these exponents together. So this right here is just log base a of a to the power of bn. But remember this rule right here, if we have log base a of a to the power of b, it's just the power. It's just the exponent that we have here. So here, if I have log base a of a to the power of bn, this is just going to be b times n. Or I could just change the order around and say this is n times b. But don't forget here that we said that b is equal to log base a of m. So this would be equal to n times, instead of b, I can replace it with log base a of m. Well, what does that tell me? That tells me, so therefore we can say right here, we can say that log base a of m to the power of n, what we have right here, is equal to this final answer right here, which is n times log base a of m. So what this means here is I can just take this n and bring it out in front if I have a logarithm here. And this is going to be really helpful when we get ready to solve equations and use logs to help us solve these equations. So for example here, if I have log base 5 of 10 to the power of 2, that's the same thing as 2 times log base 5 of 10. I can just bring this exponent out in front, just like we have right here. Let's try a couple examples. So for this example right here, we can say that this exponent can come out in front. So this would be 4 times log base 3 of 9. So now we can say that this is 4 times log base 3 of 9 is 2, because 3 to the power of 2 is 9. So then this right here would have to be 8. In our next example, we can rewrite this as log base 5 of 125 to the power of 1/2. Now we can bring this 1/2 out in front right here. So this would become 1/2 times log base 5 of 125. So then this turns into 1/2 times, and we know that log base 5 of 125 is 3. So your final answer here would be 3/2. Okay, and then in this last example right here, we can say that this right here would end up being, we can bring the 7 in front. So this would be 7 log base 36 of 6. So then this turns into right here 7 times, well, what is log base 36 of 6? Well, I have to raise 36 to the power of 1/2 to get 6, and now I can just multiply those two guys together, and I would get 7/2. The nice thing about these logs is there's multiple ways of doing these logs, just like there's multiple ways of doing exponent laws. But regardless, if you do it correctly, you'll get the right answer. So for example, like in A right here, log base 3 of 9 to the power of 4, I could just rewrite this as log base 3 of 3. 9 is 3 squared to the power of 4. So I could say this is log base 3 of 3 to the power of 8. And then I could just say that goes away. So my answer is 8, which is what we got here. So again, there's multiple ways that you could approach these. As long as you understand what you're doing, you're good to go. That's it for now. Let me know if you have any questions.